This is a simple spreadsheet that allows you to conduct a P on Z material balance for a gas depletion drive. Now, a couple of upfront assumptions that we need to make is that this is, like I said before, a gas depletion, so there is no water drive, and this is for a dry gas, so there's no condensate production. It also presumes that you have made the pre-work required, which is to come up with an average depletion trend. So you have done that work already. Therefore, you can bring the average pressure as a function of the cumulative production. So into this spreadsheet, you only paste the values of those two, right? And obviously also you have corrected that average pressure to a datum depth. So all of that is the pre-work necessary to come to the spreadsheet. Now, on the spreadsheet itself, here is where you paste that average pressure as a function of the cumulative production. These are the units. This spreadsheet has been built in, but it's easy to change to a metric system if you want. And what's in blue is calculated by the spreadsheet. So you can see here the Z factor. Actually, it invokes an Excel function. And you can see that if we go to the Visual Basic module, I'm going to bring it over to this screen, you can see that that module has a few functions that I brought from my other product that I have on the store, the PVT correlations library. So I just brought into here the functions related to gas. Now, if you do have that PVT correlations library, you already have access to those functions. But if you don't, this very workbook has a VBA module with the functions that I created related to gas. And this is the one that is invoked into that cell, which is a function of the temperature and the gas gravity, as well as the reservoir pressure read from this column. Okay, so once you have, and this is the code, it's a Hall-Yarborough correlation for gas. So once you bring the reservoir temperature in degrees Fahrenheit, you see that's a number, not a formula, and the specific gravity, again, a number. You put those in, you bring the average pressure as a function of cum production. The Z factor is calculated using that Hall-Yarborough correlation formula. So you don't have to worry about that. That's the beauty of it. And then the P on Z ratio is easily calculated as the ratio between those two. Now that is what powers this chart here, where I've also added the initial pressure with this slider. So typically you should know the initial pressure, but I'm just adding this for the sake of better visualization as to where you're anchoring that straight line on the P-on sets. But you should anchor that to your initial pressure obtained, meticulously analyzing your MDT or DST data. Okay, and then obviously the number one factor or parameter that you want to extract out of this analysis is the OGIP factor, right? So let's anchor the initial pressure there for the sake of this example, and the OGIP, which is the intercept on the zero value for the P on set here, that's the 72 that it's read off of that cell. This is where you come in and try to fit the straight line through your data, okay? And that is what will yield that OGIP value. So that label is reading off of that cell. And I've also added on top of this chart the abandonment pressure. So you can see there that that slider powers the value there, and that is the value that is labeled here, abandonment pressure. Now this is a P on Z axis, but I'm labeling with the pressure value, which is what really matters to us. And off of that, we obtain from the straight line what is the EUR, okay? So we're going to abandon the field at, let's say, 600 700 psi, that means that given that depletion trend, with that OGIP of 75, we will be able to extract 64 BCF. Therefore, the recovery factor is the ratio of those two. So all of these three values are linked to the values on this cell. So if I change the abandonment pressure, see how the recovery factor changes, and the EOR changes as well, whereas the OGIP remains the 75. So these values are varied by these sliders. The chart updates accordingly to these values and obviously to the data you bring in. And the labels on this chart are also dynamic, change with the values on the cells themselves. So there you go, a fairly simple and straightforward, very user-friendly spreadsheet. You bring your production pressure. You don't have to worry about the Z factors calculated by the Hall-Yarborough correlation implemented in that underlying VBA module. So you forget about that, and all you need to do is to move the sliders to actually feed the straight line through the data, and then you read off the chart what is the OGIP and the EOR and recovery factor for whatever abandonment pressure you decide to put in the cell with the slider. Now, future updates to this tool, I will incorporate condensate production and correction for a dual Z factor, dual phase Z factor, and I also add the Havlena-Odeh and Cole plots to properly diagnose water drive. As you know, a P on Z can be deceiving. If you do have water drive, points can align on a straight line, but they're actually already accounting for the water drive, so it may overestimate your OGIP, and the better chart is not the P on Z to diagnose water drive, but Havlena-Odeh or a Cole plot. So future updates to this tool are the additions of those plots, like I said before, Havlena-Odeh, Cole plot, and also condensate production and dual phase Z factor. Cheers.